10 biggest misconceptions about space. Space has always captivated humanity with its mystery and boundlessness. We send probes, telescopes, and even people into it to unravel its secrets. However, despite all the achievements of modern science, there are many common misconceptions about space that are firmly entrenched in popular culture and people's minds. Let's break down 10 of the most popular ones. Misconception 1. Space is always dark. When we look at the night sky, it appears black, dotted only with stars. This creates the impression that space is an absolutely dark void. However, this is not entirely true. Why is this a misconception? In the space between stars and galaxies, which we call empty, there is actually a huge amount of matter, albeit very sparse. These are hydrogen and helium atoms, cosmic dust, and molecules. And while they don't emit light themselves, they can reflect it from nearby stars. Furthermore, within the solar system, especially near the sun, there is enough light for everything around to be brightly illuminated. If you are on a spacecraft illuminated by the sun, both the spacecraft itself and everything near it will be visible. On Earth, the sky is blue because the atmosphere scatters sunlight. In space, there is no atmosphere, so there is no scattering and the sky appears black, but this does not mean a complete absence of light. For example, in the solar system, you can see the sun and other planets, and their light is quite sufficient for illumination. What is the reality? When you are in open space, far from large light sources like the sun or bright nebulae, everything indeed appears very dark. However, if you are in an illuminated area, for instance, in Earth's orbit during the day, the sun shines very brightly, and everything around seems quite bright, although the background will still be black. Astronauts on the International Space Station, ISS, often say that Earth looks incredibly bright from space. Misconception 2. There is no sound in space. In Hollywood space movies, you often hear deafening explosions, the whistle of laser blasts, and the roar of spacecraft engines. This creates the impression that space is full of sounds. Why is this a misconception? Sound is a mechanical wave that propagates through a medium, air, water, solid. For sound to propagate, particles are needed to transmit vibrations to each other. In space, in a vacuum, there are virtually no particles, so there is no medium for sound waves to travel through. What is the reality? Space is almost completely silent. You won't hear a supernova explosion or the roar of a rocket engine if you are outside its atmosphere. However, this does not mean that there are no vibrations at all in space. There are electromagnetic waves that can be converted into sound signals, but this is an artificial conversion. Scientists use radio telescopes to capture electromagnetic waves emanating from various cosmic objects, and then convert them into sounds so we can hear them. But these are not natural sounds, rather their interpretation. For example, planets, stars, and other cosmic objects emit radio waves that can be recorded and converted into sound vibrations. But this is not the sound we hear with our ears, but rather noise created by electric and magnetic fields. Misconception 3. Astronauts in orbit are weightless because there's no gravity. This is one of the most common misconceptions. Many believe that if astronauts float in a spacecraft, it means they are not affected by gravity. Why is this a misconception? If there were no gravity on the International Space Station, ISS, it would simply fly off into open space. Earth's gravity acts on the ISS and on the astronauts inside it. In fact, the force of gravity at the altitude of the ISS orbit, approximately 400 kilometers, is about 90% of the force of gravity on Earth's surface. What is the reality? The reason for weightlessness is continuous free fall around the Earth. The ISS and the astronauts within it are constantly falling towards Earth, but at the same time, they are moving forward at immense speed, about 28,000 kilometers per hour. This lateral motion allows them to constantly miss the Earth, moving in orbit. That is, they are in a state of endless falling. Imagine you jumped in a bus moving at a constant speed. You would land on the floor in the same spot because both you and the bus are moving at the same speed. Similarly, the ISS and everything inside it moves at the same speed and is in constant free fall. Misconception 4. The Great Wall of China is visible from space with the naked eye. This is a very popular myth that is often repeated. Many believe that the Great Wall of China is the only man-made structure visible from space without a telescope. Why is this a misconception? Despite its colossal length, the Great Wall of China is relatively narrow and has the same color as the surrounding landscape. It is difficult to distinguish even from Earth's orbit, let alone from deep space. Astronauts who have been on the ISS confirm that seeing the wall is extremely difficult, and it is only possible under ideal lighting conditions and at a specific angle. What is the reality? From space, without a telescope, much larger natural objects are better visible, such as the Himalayas, large rivers and lakes, and large cities at night due to their lights. NASA astronaut Leroy Chiao photographed the Great Wall of China from the ISS in 2004, but he needed a powerful lens, and even then, the wall was barely visible. From further out in space, such as the Moon, the wall is completely invisible. Misconception 5. The sun is burning. We say the sun is burning, implying that it's a giant bonfire that constantly consumes its fuel. Why is this a misconception? Burning is a chemical reaction that requires oxygen. There is no free oxygen on the sun in such quantities to sustain burning. What is the reality? The sun shines and emits heat due to thermonuclear reactions. Inside the sun, in its core, hydrogen atoms fuse into helium under immense pressure and at extremely high temperatures, millions of degrees Celsius. This process releases a colossal amount of energy, which heats the sun, causing it to glow. This is an entirely different process than burning. Misconception 6. Protection from cosmic radiation is provided by Earth's magnetosphere. We know that Earth has a powerful magnetic field that protects us from harmful cosmic radiation. But how complete is this protection? Why is this a misconception? Earth's magnetosphere indeed plays a crucial role in deflecting charged particles, such as solar wind and cosmic rays, from the planet's surface, creates a shield that prevents them from reaching Earth. However, this protection is not absolute. What is the reality? The magnetosphere cannot fully protect us from all types of cosmic radiation. High-energy particles, such as galactic cosmic rays, have so much energy that they can penetrate the magnetosphere. Furthermore, at Earth's poles, where magnetic field lines converge, the protection weakens, allowing some particles to enter the atmosphere and cause auroras. Astronauts on the ISS, although within the magnetosphere, are still exposed to higher levels of radiation than on Earth. For long-duration space flights, such as to Mars, radiation protection becomes one of the most serious challenges. Spacecraft for such missions must be equipped with additional radiation shielding, and astronauts themselves must take precautions. Misconception 7. Black holes are cosmic vacuum cleaners that suck everything around them. The image of a black hole as a bottomless cosmic funnel that indiscriminately swallows everything in its path is very popular in science fiction. Why is this a misconception? Black holes indeed possess incredibly strong gravity, so powerful that even light cannot escape it. However, this does not mean that they act like vacuum cleaners, actively sucking in everything. What is the reality? The gravitational influence of a black hole, like any other massive object, obeys the laws of Newtonian gravity at a large distance and Einstein's gravity up close. This means that if an object is far enough from a black hole, it will orbit it just as planets orbit the sun. For a black hole to suck in an object, that object must either pass very close to it, beyond the event horizon, or have a trajectory that leads directly into it. If our sun suddenly became a black hole, which, by the way, will never happen as it doesn't have enough mass, Earth would continue to orbit it in the same path, just without light and heat. Black holes do absorb matter if it gets too close, or if they are actively feeding, for example, from an accretion disk formed from gas and dust slowly falling into the black hole. Misconception 8. It's warmer in summer because Earth is closer to the sun. Many people mistakenly believe that the change of seasons is explained by the changing distance between Earth and the sun. Why is this a misconception? Earth indeed moves in an elliptical orbit around the sun, and the distance to it changes throughout the year. In January, Earth is closer to the sun, perihelion, and in July, it is farther away, aphelion. This means that when it is summer in the northern hemisphere, Earth is actually farther from the sun than in winter. What is the reality? The change of seasons is caused by the tilt of Earth's rotational axis relative to the plane of its orbit, about 23.5 degrees. This tilt results in different hemispheres receiving more direct sunlight at different times of the year. When the northern hemisphere is tilted towards the sun, it receives more direct sunlight, which falls at a higher angle, leading to more intense surface heating and longer daylight hours. This is summer. When the northern hemisphere is tilted away from the sun's rays fall at a shallower angle, and daylight hours become shorter, leading to winter. In the southern hemisphere, the opposite occurs. Misconception 9. The moon has a dark side that is never illuminated by the sun. You often hear the phrase, the dark side of the moon, and many imagine it as a part of the moon that is constantly in shadow. Why is this a misconception? The moon, like Earth, rotates on its axis. It also revolves around Earth. The fact that we only see one side of the moon from Earth is due to synchronous rotation. The moon's period of rotation on its axis coincides with its period of revolution around Earth. What is the reality? The sun illuminates the entire surface of the moon in turn. There is no dark side in the sense of constant unillumination. There is a far side of the moon, the one we never see from Earth. But it is illuminated by the sun just as regularly as the near side. When it's night on the near side of the moon facing Earth, it's day on the far side, and vice versa. Astronauts from the Apollo mission photographed and even landed on the far side of the moon, proving that it is fully illuminated by the sun. Misconception 10. Astronauts in orbit cannot cry because tears don't flow. Sometimes you hear that due to weightlessness, tears cannot flow from the eyes and will simply accumulate. Why is this a misconception? Although liquids behave differently in weightlessness than on Earth, tears still form and can cause discomfort. What is the reality? Tears in weightlessness indeed do not flow down the cheeks as they do on Earth. Instead, they form small spheres or bubbles of liquid that remain on the surface of the eye or collect around it. This can be quite uncomfortable, as these spheres can get into the eyes, irritating them or obstructing vision. However, astronauts can cry. Emotions remain the same as on Earth. It's just that the mechanism for removing tears will be different. Astronauts use special wipes or towels to remove excess tears and fluid from their eyes. This is another example of how ordinary things behave differently in microgravity conditions. These misconceptions highlight the importance of critically evaluating information and relying on scientific data to better understand the world around us, including the vast expanses of space. Science is constantly evolving, and with each new discovery, we learn more about the universe, debunking old myths and revealing new, amazing facts.